as well. So let's begin with forEach. forEach is a method that iterates over elements. So this is when you want to do something with the array. For example, log each one of them separately, like modify them individually, which you don't want to do, but yeah, you might be doing something with it. So let's say I want to loop over my favorite Pokemons and do something. So forEach will accept a callback function which gets the element in current iteration and then pass it into your callback function like this. So we have Pokemon names as our elements, so when you loop over each of them, you'll get that name for that iteration, and you get that as argument for your callback, and now you can do whatever you want with that. So say you just want to print a custom message like I love this Pokemon, right? So what this does is it goes iterate over each Pokemon and log this message. If you run that, something's wrong here. Did I miss? Yeah. So there was missing parentheses. So what it did, it went through each of the elements and then logged I love Pikachu, I love Bulbasaur, and all that. So there, another argument is I, which is like the second argument is the index, which you can use to, for example, if you want to know what index it is on, so that you can say I+1, you just want to have this as a numbered list, so that you have this 1 I love Pikachu, 2 I love Bulbasaur. So forEach does that. I don't know if these examples are are the best ones to explain this, but yeah, basically that's what forEach does. It iterates through each element. The next method is sort. Sort is used to sort, as you might have guessed. So with arrays in JavaScript, the cool thing you can do is you can chain these methods. So when you're doing sort, it returns the method that returns the array with the sorting done. So what you can do is you can call sort here and then do the loop there, which will return you the messages, the logs in an order. alphabetical order in this example. So if it was integers, it would sort by numbers. Right now it's array, so you're seeing that list of Pokemon sorted by their names alphabetically. Yeah, this doesn't have to be in this for each, but yeah, for now this makes it a bit the logs looks better, so I just leave it like that. So sort function can accept sorter function as an argument. So if you provide a sorter function which will take two arguments, which is the things they are comparing, so two consecutive elements they are comparing, it's comparing, and you can do whatever comparison you want. So what you can say is but A and B, which is, so there's one of the very simple example of sorter function. This just compares between two elements. Right now doesn't matter if it's integer or string, it just sort by its value. So you can compare two strings with this greater than or equals operator, and you'll get sorry, I just wanted to run some JavaScript. Get here so there you go. You can compare between strings. What this just did is, I hope you can see it. What it just did is, I compared A with B, string A with B, and it returned false. A is greater than B is false, whereas A is less than B is true. You follow that. That's B being higher string or something, so it comes after A. So that comparison can be used to sort. That comparison can be used to sort strings as well as numbers. So it's just like comparing 5 and 2. 5 is less than 2 will be false. Similarly, B is less than A is false. So that's how you, and it doesn't matter what's after that, right? So this will always be true, and if this has D in front, that will be false because D comes after B. So comparing strings will already allow you to sort things alphabetically and or numbers, and there can be custom sorter functions. Like if I just run this one, oh sorry, oops, this one, yeah. So here Bulbasaur, this is already sorted by alphabetical order. Say just like wild idea, or let's see like ideal use case. For example, if you have an array of objects, which is very common, there if you want to sort your entities, your objects by one of their properties value. You will have to write your own sorter function. So A and B will be those objects. For example, like let's define a new array. So if I say this, I will probably start getting, yeah. So say I have a list of items like this, right? So let Copilot work. So it gave me Bulbasaur, Charmander, and Squirtle, which was what I was looking for. So now I have my Pokemon data with four Pokemons with several properties. Just to be able to work on sorting, I would change some values here. So yeah, now if I want to sort this function, this array, sorry, I forgot what I named it, my Pokemon data. So I want to sort this by some way, and I will just log each Pokemon. Okay, for now, if I do this, it will fail because comparing two objects doesn't make sense. You're getting two objects at a time, and this doesn't make sense. What you can do is you can compare its name if they have one. So say all of these are comparing names, right? So here, if I now run that, now it's to see that it was different before. Let me log that before we do sort and stuff. So if I run that again, what you'll see is it's ordered as it is defined: Pikachu, Bulbasaur, Charmander, and Squirtle. But after you sort it by its name, now it's sorted alphabetically by its name. If I want to do the same but with its type, what I would do is I'll just change name to types, or type. Is it type? Yeah. So if I change it to type and run it again, now you'll see it's ordered by type alphabetically. So electric, fire, grass, water. And if you want to just reverse that order, you can just revert or swap these comparisons. So if you want to use HP, for example, same thing, just change this to HP. So you have two objects to compare, and you have every possibility to compare whatever you want, its properties, or call its methods, or anything, and return either -1 or 1 or 0 by like depending on whatever, and swap their positions. So -1 means don't swap. 1 means swap, right? Compared to this is greater, so swap it. And 0 is just I think you can just be like it can be -1 or anything, so 0 or 1 doesn't matter, because it always just looks at if the sign is negative or not. So if the sign is positive or 0, it just doesn't do anything, so it won't swap the elements positions. If it's less than 0 or negative, it will swap. Is it? A is less than B. Don't swap. Okay. I'm confused now. Yeah. So -1 will not swap and rest will swap. Positive values will swap. AHP is greater than BHP will swap because it has returned 1. What you can do is also use subtraction. I think I've seen that before. So A dot HP minus B dot HP. So what this does is it has those values, it subtracts. So whenever A is there's a positive value, so it will swap. When A is less than B, the returning value is negative, so it will not. Let's test that. Yes, that's exactly what it did. If I were to reverse it, I'll just subtract A dot B dot HP minus A dot HP. So that's sorting. Again, if A is greater than B, it will give you positive value, so it will swap. Positive value swaps, negative value no swap. Okay. I'm just trying to find compare function used to determine the order of the elements. It is expected to return a negative value if first argument is less than second argument, 0 if they're equal. Yeah, so that's what it was doing, but I don't know if that does have any difference to the result, right? Because what's the point of swapping or not swapping equal values? If you see 5 and 5, does it make sense to order them at all? So if they're already in order, do not order. If they have same value, do not order. So I don't see any use there. But if they're on a wrong, if they're in wrong order, swap them. That's array sorting. I think I went quite deep into that. Hi Vishwa, what's get up? So now let's go on with map function. Map function is again just like forEach, a function method that will iterate over each element. But in this case, what you can do is you can pass in a callback function, and whatever return value that callback function returns will be assigned to the new array's element, which will be hard to understand just by like explaining it in words. That's why I will show it here. So we sorted this list of Pokemons by HP. Now I want to map it. So I want to map it so that whatever I return from here will somehow array, but it will have difference. So it will have equal amount of elements, but whatever you do in the callback function will be what is in that new array. So map, just like forEach, will accept those arguments, the element itself and the index. So in this example, say I want to just return name. So this what this simply does is it will iterate over each element in this my Pokemon data component array, and sort it, right? And then it just returns just the names out of those Pokemon objects. So now if you console log new array, what you'll see is just the names: Charmander, Pikachu, Squirtle, and Bulbasaur. So that's exactly the sorted elements, sorted Pokemons were. Just for like sake of it, I'll just remove the sort function so that we have this cleaner version. So now it was Pikachu, Bulbasaur, Charmander, and Squirtle with all those data, like HP and type and all. With map, what you did is you removed rest of the elements or rest of the properties from that element and just returned name. You can return anything here that will be the element of that array. For example, you can just return apple or something. Say apple. So what this does is it goes over each element in this original array and then just returns apple for each of them. So your new array will just be a list of apples, like 4 apples. So this can be anything. So it can be fruit is apple, and Pokemon is your current Pokemon. Sorry. Right, and just added that index as well, just to make it fun, right? So now if you see, what happened is it went over each Pokemon and it created its new object with properties like fruit, Pokemon, and index, and it assigned values that we wanted to assign. So fruit has apple, Pokemon has the current Pokemon's name, and index is the index of that element itself. So yeah, that's map function. It's quite useful. Like, it's used heavily when you're doing JSX in React. You want to go over each of elements in your lists and then show them as JSX element, for example, like list items or something. That's where you're just reading over the data from these JSON objects and then returning JSX with HTML tags and attributes and whatnot, even styling and everything. So map is quite useful. The next function is filter. So array filter, as its name suggests, does filtering on array. So filtering, just like in sorting, accepts some so filter function accepts an argument, which is a callback function, where you can determine if you want to return that element or not, right? So just like sort here, you can use filter. Now what this does is, but there's no comparison between objects. You'll just get Pokemon, right, and index. Probably you won't use index, but you can. But here, so filter accept this callback function, and if you return false here, so if you just return false, this will remove everything from that array. So new array is just empty. Sorry. So new array, as you see here, is just empty. I'll remove this one for now. So so those are my favorite. I will just comment this out. So now I have this my Pokemon data, and from my Pokemon data I'm creating this new array. So we have this my Pokemon data array with all that Pokemon, and we're filtering Pokemons out of it. Nevertheless, like, no condition, just remove it. So at the end you're getting this empty array. If you want to have some conditions there, like if you want Pokemon be removed just by its type, for example, if you want to remove all electric type Pokemons, you can just return right. So what this does is it will just return all electric Pokemons. If you want to remove all electric Pokemons, you can just make it not equal. So now you see the list. Oh, electric has capital E. Okay, so that should remove Pikachu from there, right? So the list has 3 Pokemons left. So if you wanted to filter Pokemons by its type, you just removed one of them. Say if I want to filter Pokemon by its name, anyways, so this is the concept. If I just want to remove Pikachu, or if I just want to remove Pokemons that do not have enough HP, for example, if Pokemon has HP greater than, say, 100, so I just want to see all the Pokemons that have HP more than 100, then I get this, just Bulbasaur, because Bulbasaur has 120 HP and rest seem to have less than that, so 90 and 100, right? So we wanted more than 100, so only Bulbasaur returned. So that's how you filter arrays. The last method is reduce. Reduce method is a bit different than all the methods you saw. Reduce method works by aggregating elements. So how it works is you want to go over an element and you'll keep a buffer, or I think it's called accumulator, where you accumulate stuff. So you have this accumulator and your current element, and you do something with the current element and you modify the accumulator, and then go to next one. When you have this aggregating stuff or things like that, so aggregation basically. So if you take an example of adding all the numbers in an array, so I have 1 2 3 4 5 6 7 8 9 10. That's my array, and what you want to do is you go over each element and add it up and show a sum. So how would you do if you were using, for example, forEach? Let's use for. So if you're using a for loop, what you'll do is var something like this, and what you'll do is you first initialize sum with value 0, and what you'll do is for every element you'll just add that to sum. There you go. Right, what this will end up is what this will end up doing is it will update the sum's value to the sum of each of those elements. So if you log this sum, you'll be seeing sum equals 55. That's the sum of this whole list of numbers. So if you look at this, this is basically what you do usually, but with reduce function it's much it looks much better. So you can go and my number array dot, I could have shown that with forEach as well, but for now that's good. I can reduce, oops, there was some suggestions, accumulator and current value, right? So usually this initial value is always 0. So so what happens is you have something called accumulator that is passed in this callback function every time, and current value is just like in any other methods we saw before. It's the current element. Now returning returning whatever in this this function will be returned to the accumulator. That's the difference. So what happens is you still have that accumulator, and you can do anything with the current element, and then return something that will update the element accumulator, something like this. Here sum was our accumulator, and we just added each element to that accumulator, and it ended up adding everything to that accumulator variable. So here just like this one, accumulator is initialized here with initial value of 0, and for each iteration it will add current value, which is our number, to that accumulator. So for the first element it will be 0 plus 1, and returning value will be 1, and that will be now set to the accumulator. So this should return exact same thing. So if I run that again, you get the same value, 55, my reduced sum. It might be confusing for people who are not already familiar with this, but it makes it much cleaner. This can be used in several other use cases, and it makes it quite makes your code quite easier to read. My sum is just one of them. You can actually do like any kind of like summarizing an array or something like that. So you end up with just one thing at the end, whereas other functions we saw, they always returned array instead. And yeah, so that was reduce, and with that we have come to an end of this video. We looked at all the, not all, but most of the JavaScript array methods. I hope that was helpful to you and you understood a bit more about array functions in JavaScript. They're quite important to learn, and they'll be very useful for anything, everything. So yeah, hopefully you liked it. If you liked it, please like the video, and if you're not subscribed, please consider subscribing. That will help me improve my channel, improve my videos. So with that, bye bye.